First thing I'm going to do is position our origin. The origin is in the middle of the block. So I'm going to go to my stock setup, and you have a couple of automated choices here. We're going to use top middle. Now I need to create a pocket and then an outside profile. So we need curves to tell the tool where the boundary is. So we're going to use silhouette boundary and select all surfaces. So you get the silhouette on the outside and the inside. I like to make my machining curve active. So when I go to make my work step, it knows to use the active curve. Now the total depth is 2 inches, but we're going to go and cut both sides. We'll do the top side and the bottom side. Now because of the high-speed machining toolpath, I can go at a whole inch depth because the high-speed toolpath gives it a nice even chip load. I'm going to combine that with the helical plunge. Now I'll make the outside curve my active curve. We'll create a contour work step. We'll go a full 2 inches, but we're going to step it down 1/4 of an inch each time, and we'll leave a finish allowance for another contour operation to follow. Now you can see we're cutting on the inside of that curve. I still want to be climb milling, which is on the left. So rather than reverse the tool path like you see here, reverse direction, that would be convention milling. We're going to reverse the curve itself. So we're climb milling. Because there's a heavy amount of material on these corners, I'm going to add a total stock. Now we're going to make a finish pass. Next, we have to rough all the material down to the flat surface on the top. So we're going to use the machining wizard for that. We'll leave a finish allowance for a ball end mill. Now we'll go in with a finish pass. The path offset, I want the ball end mill to drop down the wall less than the diameter. So it takes the ball end mill, puts it tangent to the bottom of any chamfer radius and such. Our step over, if you were to put in 1/10 and you were to tighten up the tolerance to 1/10, you would get the best surface finish. Now if that was a semi-finish pass, just to remove the cusp left over by the roughing operation, I would just leave a finish allowance and then go in without a finish allowance. Now to machine the other side. So we're going to use another coordinate system for that. And we'll place this right on top of the other one. And we'll move it around. We'll rotate around X 180 degrees, selecting only our coordinate system. And we have 2 inches to move. Now I want to use the same machining strategies as I did on the top. So I'm going to open up our spreadsheet. I'm going to highlight all of our work steps. Right mouse click and copy them. And we're going to click on the total field and it pastes just above it. So we're going to paste the work step. And the 2x is going to represent our bottom coordinate system. Now we don't need to rough and finish the outside. We went to full depth for that. So I'm just going to right mouse click and delete the work step. Now for 2x pockets, we have to assign the bottom work step, bottom coordinate system, and do the same for the other operations. Okay, both the top and bottom have been completed. So I've used coordinate systems for this side, that side, and over here. We're going to just place one right in this location here. And I'll call that side 1. Now we're going to go to the view menu and I'm going to line that coordinate system up on geometry. Choose only circles. And I'm going to pick that circle right there. Now I'm going to create a curve from a face boundary. And we're going to machine this pocket. Depth is 0. The curve in relationship to the coordinate system is at the depth of the pocket, so it knows that automatically. Go to advanced. We're going to change that to a flat end mill. And we're going to use the side coordinate system. Now for the holes, I'm going to use hole recognition. And I'm going to take a measurement of the thickness . So about 200 thousandths. Go right to advance. Tool 4. Diameter is 0.067. Go 0.2. It knows it's starting by hitting auto. It knows that the pocket has been cut and it's starting below the surface. So our rapid, we want to be above that. Now let's put it all together and see what we get. Now for our G code, we'll turn off all the 2x operations by right mouse clicking and produce the G code. And we turn those off, turn these back on. We'll leave the side holes out and produce the G code, deactivate these, and a third program. That concludes this video.